All right, it is 1:30 Eastern, so I'm going to go ahead and get started. Welcome to Maximum Overkill at Code PaLOusa, subtitle Using Terraform to Set Up an AWS-Hosted Personal Website. Hi, I'm John. I go by GeneHack most places online. That's my Twitter handle down there in the corner. It's going to be on all my slides, so if you're going to tweet about this, please include me so I know what you're saying about me online. If you have any questions along the way, I'm going to stop and have various points where I ask for questions, but feel free to throw stuff in the chat. I'll try to keep an eye on that as I'm also giving the talk, and we'll see how I balance all these multiple inputs. I originally wrote this talk for my local user group back at the beginning of 2020. And I talked about how one of my goals for the year of 2020 was going to be taking back ownership of all my stuff on the internet, getting all of my stuff off of Twitter and Facebook and GitHub and into my own domains and my own sites, and like reviving my blog and everything. And then actual 2020 started to happen. And so the plan has had some hiccups because I don't think anybody's having the 2020 they intended. But this part of it, moving my blog into AWS hosting, actually got done. So the whole idea started with a website. I've had genehack.org for about 20 years now, which means I get all of the spam. So because the site's really old, it's a bit of a mess. And one of the things I wanted to do was separate out the blog content from the other content that was on the website, like my resume and stuff like that. So really the story all starts with a blog. And at this point, I should issue a disclaimer. The talk is called Maximum Overkill for a reason. What I am doing to set up a statically generated blog site is far more complicated than it needs to be. I'm sort of killing a couple of birds with one stone here because I also needed to learn Terraform for work. So if you just want to set up a statically hosted personal website, use GitHub pages or GitLab pages or Netlify or a VPS and rsync, as this tweet suggests, or any of a dozen other solutions that are far simpler than what I'm about to spend the next hour talking about. But if you want to get some experience with Terraform and using it, this is a good sort of starter Terraform project that's a little bit more involved than some of the starter projects. So first, what's Terraform? If you go to the Terraform website, terraform.io, they will hopefully tell you that Terraform is a cloud agnostic infrastructure as code framework by HashiCorp. You can see HashiCorp right here. It's the company that makes Terraform. This is a bad definition because it doesn't really tell you anything about Terraform. So first, what's infrastructure as code? Sorry, the chat does not auto scroll for me apparently. So if I'm missing stuff, feel free to, I don't know, have Tina yell at me. So what's infrastructure as code? The idea behind infrastructure of code is instead of setting up your infrastructure by hand, you automate it. And there are a couple of, broadly speaking, two different ways you can go about automating setting up infrastructure. You can either write code that does the work for you, and that's called the imperative method. You basically give commands, build this thing like this. Or you can use a declarative system. And the way declarative systems work is you don't tell it how to do the work, you just tell it what you want. You say, I want this kind of thing. I want it to look like this. And then the system figures out how to do it, which sounds like a good idea. Terraform is one of these declarative systems. You don't tell it what to do, you tell it what you want, and it figures out how to make that happen. That means it needs to keep track of the state of what's out there so that it can compare the state of what's currently out in wherever you're trying to build things, and compare that to where you want to go. And then it kind of looks at that current state, looks at the future state, and figures out how to map from one to the other. Terraform has really great documentation. Their site is fairly lovely and fairly easy to get around to. And it has a pretty good getting started guide that covers sort of the basics. It'll walk you through basically spinning up an EC2 instance or the equivalent of an EC2 instance on Azure or Google Cloud. You can kind of pick AWS or Azure or Google Cloud, and it'll walk you through that. If you've never touched Terraform before, that's a great place to start. But I'm also going to give you kind of a rapid, more throw you in the deep end introduction to Terraform as we go. So we want to use Terraform to set up some static site hosting on AWS. So what does the architecture for static site hosting on AWS look like? It looks a little bit like this. So we have your computer here, talking over the internet to sort of the edge of the AWS network. And the first thing we're going to do is we're going to talk to a DNS server at Amazon, and the DNS server in AWS is called Route 53. So there's a Route 53 zone. We're going to set up a Route 53 zone. We're also going to set up a CloudFront distribution. CloudFront is the AWS content distribution network. So this will give us caching and make our site fast from anywhere in the world. We also want to serve our site over HTTPS because we're good netizens. So we're going to use Cert Manager, which will interact with Route 53 and with CloudFront so that we're serving our site with a generated TLS certificate over HTTPS. We're also going to set up a couple of S3 buckets, one to hold the website content itself and one to hold the logs for the website. And then finally, we're going to set up an IAM role, which is basically a user, and a policy, which is a set of security permissions to allow that user to update the content in the site bucket so that we have a secure way to do that. And that user won't be allowed to do anything other than update the content. So kind of a least privilege approach. And just as a reminder, if you're looking at this and saying, God, this seems really complicated for something that could be start Nginx and pointed at a directory, yes, it is. Again, reminder, this is kind of the maximum overkill approach to solving this problem. All right, so enough of architecture and where we're going. Let's see some code. And if you want to follow along at home, if you prefer to look at the files instead of the excerpts I'm going to show you, get.genehack.net/genehack/Terraform genehack blog has all of the code I'm about to show you. So first, if we just go into that repo, this is how the repo is organized. There's a couple of directories, there's a license, several files. So we're going to concentrate initially on these top level files down here, main.tf, outputs.tf, and variables.tf. Terraform files use .tf as an extension. And the way Terraform works, it's basically directory scoped. So when you start Terraform running, it looks at everything that's in one directory that ends in .tf and kind of gloms all those files together and treats it as one thing. So splitting this up is less a requirement and more a convenience, as I'll talk about as we go through the talk. So we're going to first look at the variables.tf file. And as you might guess from the name, variables.tf is stuff that you can change or that might vary from this. So hypothetically, you could use this to generate some static site on a different domain. It's set up to default to setting up genehack.blog because that's where I wanted to set it up. And AWS, if you're not familiar with how AWS works, everything in AWS is organized into regions, which are sort of broadly mapped to different geographical sections of the country. Which region you're using for your stuff has some minor impact on what services are available. It has a slightly larger impact on pricing, and it determines whether or not your site is still working when the rest of the internet has fallen over because US East 1 has eaten it again. So these variables, if you want to change the values of these when you're running Terraform, you can specify that on the command line like this. And where you say -var and the name of the variable and give it some other value, and that will override what's set here as the default. We'll talk more about that towards the end when we talk about actually running Terraform. Next file is outputs.tf, and this tells you what's going to be spit out when you run the Terraform script that's in this directory. So we're declaring a couple of outputs. One is the name servers, and I'll talk about why that is shortly, and the CloudFront ID, the ID of our CloudFront distribution, and I'll talk about why we need that too. The important thing about outputs is just to keep in mind, this is what's going to be spit out when you run the script at the very end. So that's outputs and variables. And so we'll charge onward to where the action happens in main.tf. So this is the whole overall structure of main.tf. Don't try to read this, it's kind of too small, but the point of showing you the whole file at once is just to point out There's not that much to it. I mean, you can kind of see what's going on. And if you squint a little bit, you can maybe see that there are these top level module declarations that R53 zone, site main, and R53 alias. And you might remember, hey, we saw those before. Those are directories back at the top level of the repo. So that kind of tells you how this is going to work. Basically, we're loading each one of those as a module, and we're going to execute each one in turn, and that's going to do various things. And the way Terraform works basically is you're constantly taking the outputs of one thing and hooking them up to the inputs of another thing. So that's part of the reason. Part of the reason why files are organized to split out outputs and variables is because the outputs are frequently something that you're going to be using as a variable in another spot. So having the files organized like that is helpful. So if we jump back in to main.tf and look at just the top of it, you can see we're declaring some things called providers. This is a good example of, so Terraform is configured using something called HCL, which stands for HashiCorp Configuration Language. And the way that language works is basically you have some sort of keyword, and then you have a name for it. Sometimes there's a second thing here, which gives you a specific instance name. And then there are some curly brackets, and inside the curly brackets are various key value pairs that are going to be given to the thing you're trying to set up. So here we're declaring that we're using the AWS provider. We're using a provider called AWS. We're also using a couple of other providers, random and template. So what's a provider? Providers are really central to the whole notion of the declarative way that Terraform works that I talked about back at the beginning of the talk. When I said that you tell Terraform what you want and it figures out how to do it, well, the code that's responsible for figuring out how to do it lives inside of all of these providers. And there are a ton of them. This is a tiny section off of Terraform's website showing just the top of the list of what they call the major cloud providers. So all of these things, plus all of these other sort of sections, you can use Terraform to drive other configuration management software. You can use it to drive various networking and system management tools. Use it to directly set up databases outside of clouds, all sorts of stuff. The list of plain cloud providers, not major cloud providers, is like 4 screens long. So pretty much anything you want to automate on an infrastructure level, Terraform probably has a provider for it. And then there are also a wide range of community provided providers too. Community provided providers is a weird thing to say. So if we jump back into main.tf and look at this a little bit more, you can see what we're doing here with this version line, which we have in each one of the providers, is just declaring a minimum version of that provider to be required. It says, it has to be, you have to be at least this tall to ride this ride. For the AWS provider, we're also setting a variable called profile to default. What that does is AWS access is typically on the command line controlled via a file at .aws/credentials that's in the INI format. And all that does is let you say, here's my secret key, here's my key and my access key, access secret, and map that to a name so that you can have sort of multiple AWS accounts that you use to access things. So here we're saying we're going to use the default profile from the AWS credentials. That's right here. And then here we're telling it what region we're going to be operating in. And we're saying that's going to come from the region variable. So var dot is the way you refer back to the things that you declared in the variables file. So if you recall in the variables file, we said variable region and said it was US West 1. This is how you pull that value back out. If you've ever programmed in something like Shell or PHP or Perl, where they use things like $signs to indicate that something is a variable, this is basically the same idea. You're saying, hey, give me the variable that has the name region. All right, this is a good time to stop and just kind of pause and say any questions about anything up to this point. Nope, everybody's hanging in there. Okay, cool. Feel free again to shout out in the chat if you have any questions. back to the high-level overview of main.tf, we've gone through kind of this portion of it. And so we have the 3 module sections left that we're going to step through. So let's look at the first one of those a little bit more closely. Here we're going to set up a Route 53 domain name zone and a certificate. We're going to use this module r53.zone. It's going to come from, this is the source, this is where the files are going to be read from, the Route 53 directory in the current working directory. And here we're passing a variable value into the Route 53 zone file. And again, that came originally from variables.tf where we set up the domain. We're also passing in a second argument to the module called comment. This is how you do string interpolation inside a Terraform file. Here, like this will turn into zone for, if you're using the default value for domain, zone for genehack.blog. And this just shows up in the AWS console interface. It's a helpful way to let people know that they shouldn't touch this stuff because Terraform is taking care of it. So if we go back and look in the repo at what files can be found in that R53 zone directory that we're loading, you can see there are 4, unsurprisingly, main outputs and variables have the same function as the stuff we've already seen, but there's also a new TF file, versions.tf, that we haven't seen before. That just allows you to specify a required version for the Terraform tool itself. This is in all my modules. It's kind of a best practice to include it, but it's not required. I'm not going to talk about it anymore for the other modules that we walk through, but you can say you must be using at least 0.12 of the Terraform tool to use this module. If we continue on and look at the variables.tf file in the module, you can see we're declaring a couple of variables. One is the domain and the other one is the comment. And you might remember back in main.tf, those were things that we were passing in to the module. So variables, the point of variables.tf for modules is this is sort of how the module declares what its inputs or its arguments are. This is the things that it's going to accept when somebody calls it to run it. And we're passing in the top level of our domain and we're passing in a comment. We provide a default comment, but that will be overridden by the comment that gets passed in. And then in the Route 53 zone outputs.tf, we're gonna basically output some values from this module that can then be used in other things in main.tf where this module is included. So we're gonna output the ID of the zone, the ARN of the certificate, and the name servers that the zone ends up getting declared to use. So this is how information comes back out of the module. You can think of it, if you've programmed in a typed language, as sort of analogous to declaring like what a function returns. This is what's going to come back out. And again, most stuff in Terraform is all about taking the outputs from one thing and hooking it up to the inputs of another. And that's why we're splitting out variables and outputs into their own distinct files. So we go back to the top level outputs.tf, the thing that is going to be spit out at the end of the Terraform run. You can see we're taking this Route 53 zone name servers output, and we're turning around and saying, hey, take the output from module Route 53 zone name servers and print it out and call it name servers. Because when we run this script, we're going to need to know what name servers are assigned to the zone so that we can turn around and tell our domain name registrar, hey, this domain name uses these name servers so that everything works. Any questions about any of that? All right, folks are hanging in there. Sounds good. Let me get my notes caught up to where we are. Okay, so if then we go and look at the Route 53, R53 zone main.tf file. Again, this is the whole thing, mainly not so that you can read it, but just to give you an idea of what the overall structure is. You can see it's not that big. So let's step through each one of these sort of stanzas in turn. We start off declaring another provider. And the reason we have to do this is because of a kind of an oddity in the way AWS works. Anything related to the cert manager service has to live in US East 1. And because we're not using US East 1 as our region, we have to define a new instance of the AWS provider pointed at the US East 1 region, and then give it an alias so that we can refer to it differently than the main AWS provider. And then we're going to set up a couple of what Terraform calls resources. Resources are basically actual things that are going to be created somewhere out in the world, in the cloud or somewhere. So we're going to create a AWS ACM certificate resource named cert. We're going to use the special US East 1 version of the AWS provider that we just made to create it. We're going to ask for that certificate to apply to the domain name that we passed into the Route 53 zone. And we're going to validate that we're allowed to do this via a DNS lookup using a host that we're going to create on the next screen. We're also going to create a Route 53 zone. We're just going to call it main because we're unimaginative. And we're going to make it for the domain and put the comments on it that we passed into the file, telling people that the zone is being managed by Terraform and they should leave it alone. Again, if you recall back in main.tf, we're passing that domain, the domain and comment values that we're using here are being passed into the module back in main.tf. And the domain value in particular is coming from the top level variables.tf file. Back in Route 53 zone main.tf, we're going to create a couple other things. One is a domain name record that we're going to use for cert validation. And what we're doing here is setting various values, pulling them out of the cert. So when we created the cert and told it we were going to validate it via the domain name option, some variables were set in there, and we just need to pick those up and relay them into this resource so they get created in the appropriate zone with the appropriate values and the records that are needed. And then finally, we're going to make a certificate validation cert using the provider, the certificate we just created, and the validation record that we just created. This kind of hooks everything up together so that it all works. And that at the end, if we run just this bit, and we've got all the domain name stuff set up properly so that the cert validates, we will have created this. We've got the Route 53 zone, and we've got the certificate manager. Any questions about any of that? All right. Folks are hanging in there. Cool. Okay. Now, if we jump back to main.tf, the next module we're going to be evaluating is called site_main. And this is getting passed in a whole great big number of things. We're going to read the files from site.main. We're going to give it the region we want to run stuff in. We're going to give it the domain we want to run stuff in. We're generating several other variables based on the value of that domain. So we're going to have a couple of buckets and a deployer user. We're passing in the ARN, which is just sort of a unique identifier for the certificate we just created. And we're setting something called not found response path, which you, based on the value of it, you can probably guess what that's for. So a lot of stuff getting passed in. You might expect that the module is going to be a little bit more complicated, and it is. So if we look at the files in site main, you can see the same files we saw in Route 53 zone main and outputs and variables and a version declaration. But there are also a couple of new JSON files that have policy in them. So what are those? We'll see those in a minute. They're template files. We're going to use them to generate some security policies to control access to stuff. So if we look at the variables file in site.main, you can see there are entries for all of the things that we were passing in from the top level, which makes sense. Again, variables is the way you sort of define what the inputs to a module are. So the region and domain we've seen before. Site bucket name, it's going to be the name of the S3 bucket we're creating to hold the site assets, resources. Then we're going to have a bucket to hold logs, access logs for people hitting the site. We're going to have a deployer, which we'll talk about what that's in a minute. It's related to the IAM role that's going to have the access to upload new versions of the site. We've got the certificate ARM I talked about. We've got routing rules, which is a variable we're not actually setting a value for. So we provide a default value. If something has a default value and you don't provide one, obviously just the default will be used. So you don't have to set a value for everything. Still more site variables. The default root object is sort of what the default directory page is going to be. So index.html is a good choice. Not found resource path. I'm a bad coder because these should have comments telling you what they're for. But not found resource path is what the page that will be served if there's a 404 error. Continuing on, I'm not even going to talk about, so I'm not going to talk about forward query string. It's pretty obscure. Price class, you can basically configure CloudFront to provide different levels of service. And the higher level of service you get, the more it costs. Price class 200 is kind of the bargain basement level of pricing, which for what we're doing here is fine. And then finally, there is in output.tf, we're going to output the CloudFront distribution, which again, if yeah, I didn't have a slide in here. This actually gets output back towards back in the top level outputs.tf. We're going to use this to do caching validation when we're maintaining the site, and I'll show you how that works here in a minute. Any questions about that vast panoply of variables I just shoved you through? Okay, so now let's take a high-level look at the site main/main.tf. This is not a small file, and you cannot read any of this, and you can sort of almost barely make out the overall structure. So this is definitely the meat of what's going on in this repo and the majority of the Terraform stuff we're going to walk through. Yeah, it's kind of crazy. So let's take this one bit by bit. The first thing we're going to do is make a password. So this is the first time we've seen an example of a resource instance. So no, actually, that's not true. I take that back. Never mind. I'm going to do that in a slide. Forget what I just said. So we're making a resource here. We're going to generate a password. We're using the random module. We're going to generate a cloudfront secret. It's going to be 24 characters long, and it's going to just use normal alphanumerics. We're not going to use any special characters. Then we're going to declare something new, which is a data element. Data is basically a way to have a structured bit of stuff that you can pass around like it's a Terraform input or output, but it doesn't correspond to a resource. It's just something you've generated within your Terraform script. So here we're using the template module to make a template file data element, and we're going to call it bucket policy. We're reading the template from this path. So you may remember this is one of those JSON files I called out in the root of the repo. And path.module is a special internal variable that contains the path to the module. So this basically gives you the path to the directory where the module is running. So we're going to pull that file out of the template. We're going to declare a couple of variables that are associated with this instance of the template. And as you might expect, those are going to be interpolated into the template. So we're going to take the bucket name and the password that we just generated. And then it's going to combine with that template to end up generating this policy. So if you're not familiar with AWS IAM security policies, what this says is allow any AWS account to get objects out of an S3 bucket. That S3 bucket is this particular S3 bucket, and the value of the bucket variable will be substituted here, as long as there's a condition, as long as in that request, the AWS user agent equals the secret. So basically what we're doing here is setting this up and saying, hey, this is a policy that says you can download anything you want out of this bucket, as long as you do it using this particular user agent string in the request. And the reason for doing this is because what we're eventually going to have set up is an S3 bucket that's public to the internet, but that's also accessed through that CloudFront distribution. We don't want Google to somehow accidentally find the S3 bucket and index it too. because then it'll see this, Google sees the same content under 2 different URLs. It'll penalize that content in the results algorithm. So what this does is it basically locks things down so that sorry, should have that architecture in here again. In this architecture here, the only thing that's allowed to talk to this bucket is the CloudFront distribution, even though technically it's wide open to the internet because you are requiring that password. All right. So now we've generated that policy. We're going to make a bucket. We're going to make the site bucket where those site assets are going to live. We're going to call it the thing we passed in. We're going to give it the policy that we just generated. And this rendered bit here on the end causes the variable interpolation to happen. And then we're going to set that bucket up to host a website with the index document and the error document and the routing rules that are coming in from the variables. Then we're going to set up the permissions necessary to host the bucket. So this is just a public access block is the way you control public access to an S3 bucket. We're kind of blocking public access except for this. This bit is the part that lets it work as a website. These bits keep it from being completely wide open to the internet, which is good. Most of the time, you don't want your S3 buckets to be exposed to the internet at all. But if you're serving a website out of it, obviously, it's got to be hosted a little bit or exposed a little bit. Next, we're going to create a deployment user. So this is the hard hat in the architecture diagram. It's just an IAM user, and we're going to give it the name of the deployer variable. Force destroy here is a thing that tells Terraform, hey, if you're running this and the user already exists, feel free to go ahead and destroy it by force. Amazon in general doesn't like you to destroy IAM users unless everything is cleaned up behind them in advance, and this handles that edge case. And then we're going to have another policy file generated from a template for the deployer role. We're going to pass in a variable to it. And here is that policy. What this basically says is allow access, allow these particular S3 operations to the bucket, allow this longer set of operations to everything inside the bucket. That / at the end is important. And we're going to interpolate the bucket name in both places. And then we're going to use the template file to actually create the policy document for site deployment, again, using the rendered version of the file. And we're going to take that and attach it to the user. So we're going to take the policy that we just made up here and attach it to the user. And that's going to give the user permissions to access that bucket. Those last 2 screens of stuff, we're basically making a special group for the deployer user and then setting the permissions on the bucket, setting the bucket group to the deployer user and setting the permissions on the bucket to allow group read write in Unix terms. But that's how it works in AWS. It's a little bit more complicated. Next up, we're going to make the CloudFront distribution resource. So we're going to set it up, we're going to turn it on, we're going to make it work over IPv6. We're going to use that bargain basement price class we defined in the variables. We're going to tell it to use HTTP2 by default because it's 2020. We're going to tell it to use index.html as the default root object, and we're going to make it accessible via the domain name as one of the aliases that you can use for this CloudFront distribution. And then finally, we're going to set up a bunch of stuff around the origin policy that basically controls how that gets accessed internally. And then finally, and most importantly, this custom header bit here is where we're telling CloudFront to use that password that we generated when it's talking to the bucket. So any request that gets relayed through this CloudFront distribution will get this user agent header added, which contains the password, which makes the whole thing work. And we're done. We've set up our architecture. So the last bit set up the role, the policy that allows the role to talk to stuff, the CloudFront distribution here, and the 2 buckets, and hooked everything up. Anybody have any questions? All right, so that's how the Terraform, how the Terraform files look, control everything. How do you make it all go? And there are a few different sort of subcommands you use with Terraform. Terraform is a command line tool. The HashiCorp site at terraform.io will tell you how to install it, help you install it. Once you've got it installed and you are working out of your Terraform directory, the first thing you need to do is initialize your providers. So Terraform init will look at the files and the modules that are in your directory, figure out what providers they use, and then go out to Terraform's provider registration facility. You can think of it as basically like npm for Terraform or PyPy for Terraform, and download just those providers into a .terraform directory in your working copy. So one, you'll want to ignore .terraform in your git configs. And two, if you ever edit your Terraform files and add a new provider, you need to rerun Terraform init so that it kind of goes back out and grabs those files again, kind of like rerunning npm-i or npm install when you add new modules. Once it's initialized, there are two, broadly speaking, two different ways you run Terraform. One is kind of a test run. So you run Terraform plan, and Terraform will look at the current state of everything in your cloud and what the state the Terraform configuration says should be there, and it'll figure out what the differences is, and then it'll tell you, I'm going to do these things to make the new state match the desired state, but it won't actually do any of them. Terraform plan is basically just a dry run. It'll figure everything out and output it and then just quit. And then there's the version that actually does the work, which is Terraform apply. Terraform apply will again figure out what needs to be done, and then it'll stop at the end and say, hey, I'm about to do this stuff. Is that okay? And you have to actually specifically type out the word yes, which is good because you sometimes realize that you don't want to apply it. And then finally, this is the place, not finally, but this is, if you recall back at the beginning of the talk, I said you can override variables with the -var. This is how you would do that. So this would run a Terraform plan, but instead of using whatever the file said the value of var.domain was in the top level main.tf, it would use my.site instead. Really important note about running Terraform. Once you run Terraform for the first time, a file will show up in your directory, in the directory where you ran it. It's called a state file. It will be named terraform.tf state. And what this contains is a big hunk of JSON that is basically the serialized state of where Terraform got your remote resources to. This is important because there's some stuff in that file that can only be determined by basically doing the operation out in AWS. Like if you're making a resource and it's generating something that has a particular ARN, you need to know what that ARN is so that you know if something has changed on the remote side, but it has to be recorded somewhere. And that's in the terraform.tf state file. If you're just running Terraform for a personal site and you're the only one who maintains it and you always do it from the same machine, this doesn't matter that much. If you're part of a team of sysadmins that's using Terraform to maintain infrastructure for your work, or if you are maintaining a personal site but you do it from a couple of different places, you need to figure out a way to sync this TF state file or you're going to be in a world of hurt. There are a couple of different solutions for this. One, Terraform will happily sell you access to a cloud instance where they manage your TF state file for you. Or there are providers you can use, things you can set up in your Terraform config to upload this to a dedicated S3 bucket every time you run Terraform, and then re-download it before it gets run the next time. So you can keep track and share that state. You also don't want to remove this file. That will, again, cause you a world of hurt. So that's just something to be aware of when you start using Terraform for real. And then finally, if you set this sort of environment up where you have a statically hosted website behind a CloudFront distribution, you will probably at some point want to update some of those files. And then at that point, you will discover the bad part of having things behind a CDN, which is that it's caching stuff and nobody's seeing your new blog post and it's really annoying the first time you have to figure this out. So this is the special magic command to run with the AWS command line utility, saying, hey, CloudFront, create an invalidation plan for this distribution ID and for basically everything in that distribution ID. This will cause a massive cache invalidation so that your new content shows up, which is good. That CloudFront ID value comes from way back in slide 19. We're on slide 83 now. Way back in slide 19 in the top level outputs.tf. I told you I would tell you why we were printing out the CloudFront ID. It is so you can pick it up and stick it in your environment to generate cache invalidations when you're uploading new content. And that is the end of Maximum Overkill. I want to say thanks to a few people. One, thanks to GitHub user Skyscrapers, whose Terraform website CloudFront repo was the main source of inspiration for mine. I basically refactored their content into a lot of the code that I just showed you. I also want to thank my employer for giving me time to write this talk and present it to you all. We do custom software development and technology consulting. If you need any custom software development, please hit me up via whatever method is convenient for you. Like to thank the sponsors of the conference, Amazon Alexa, Software Guild, Modus, and Andromeda Galactic Solutions. Without them, we wouldn't be here hanging out virtually today. And then finally, I'd like to thank the organizers and the volunteers for their time and effort in putting this together, and particularly Tina, who has been a lovely moderator and made this whole experience much more pleasant than other virtual conferences I've been part of. It's nice to hear another person's voice when you're doing this stuff. And finally, thank you for coming to the talk. Hopefully this made sense and was not just a fire hose of angle brackets and squigglies being hosed at you. And I'm happy to take questions. If anybody has any, if anybody wants to ask the question out loud, holler in the chat. We can get Tina to add you so that you can share your audio with us. And I will point out that this is the changelog from my weblog, which I set up January 1st using all of this Terraform stuff. I did it New Year's Eve and New Year's Eve or New Year's Day. And then in the stuff that I finally need to finish section, we have writing the post about how this all works, which is basically the talk I just gave instead of writing a blog post. Anyway, happy to take questions. Thanks for coming. That's it.
Hey, thank you very much. That was very informative. I just started writing Terraform about 3 weeks ago, and so you answered a lot of my questions that I have had. So I appreciate that. It was good.
That's awesome. Thank you.
Yeah. Thank you, but thank you very much.
All right. If nobody else has any questions, I'm probably going to drop off and go. I'm in Pacific time, so it's almost lunchtime, and it's Friday, which means it's almost beer time. So I'm going to go probably have the post-talk adrenaline shakes and take care of those couple of things. Thanks everybody who came, and I'll see y'all online. Bye.